Hello, students. Today we will learn another way to solve systems of equations other than graphing, and that's by substitution. This is an algebraic approach. It's not visual like the graphing one was. However, you're still solving for the point where the two lines intersect. You're just doing it algebraically. So this will really test your solving equation skills. If you're pretty good at that, this will reinforce that. If you feel like this is a weakness of yours, this could help you get better at it. So let's see what this is all about. So we're going to go ahead and start with a simple example. When you solve a system of equations by substitution, remember what it means to substitute. You're replacing something with its equivalent or with something that it equals. Replacing with equivalent. Okay, so the first thing we're going to do is we're going to go ahead and start by solving for a single variable. If you look at our two equations, it's totally your choice which one you want to start with. But if you look at this first equation, it's already solved for y. So I'm going to start there. This will be the easiest approach. So if I look at this, what this means, 3x is equivalent to y. They equal each other, right? That's what the equal sign means. So in the second step, I'm going to substitute that 3x, sorry, not 1, 2. I'm going to substitute that 3x for y in the other equation. So I'm going to write the other equation down. And since 3x equals y, I'm going to take y out, and I'm going to put 3x in its spot. So it's going to look like this. X plus 3x equals 8. Okay, so what I've done, this equation now only has one type of variable, whereas the one above it had two types of variable. When I have an equation with only one type of variable, I can solve for the value of that variable. So that's why we do this substitution. So let's go ahead and solve this equation now for x. We will combine our like terms. X plus 3x is 4x. Remember, there's an imaginary or an invisible 1 in front of that x. So 4x equals 8. And then we'll divide both sides by 4 to get x by itself. And x equals 2. So I found the value of one of my variables. Now remember, we're trying to find that point where the two lines intersect. So the x value of that point is 2. Now I will rewrite that first equation in the first box, y equals 3x. And since I now know that x equals 2, I will replace the x value with 2 to solve for y. So y equals 3 times 2. And 3 times 2 is 6. So now I know that y has a value of 6. And so the point where the two lines intersect is 2, 6. So if I was to go into my calculator and graph these, that's where they would intersect. I can also double check my answers algebraically by replacing both of the x's in my equations with 2 and replacing both of the y's in my equations with 6. And it will make both of those equations true. So this is the only point that makes them both true. So in the first equation, for example, if I replaced x with 2 and y with 6, it would be 6 equals 3 times 2. That is true. In the second equation, it would be 2 plus 6 equals 8, and that is also true. Now let's look at the steps that we just did. Let's verbalize them and write them out. So these are the steps to solve a system by substitution. Step 1, you're going to find one of your equations that has a variable term that has a coefficient of 1 or negative 1. Remember, the coefficient is the number in front of your variable. Let me show you what I'm talking about. So this y in the first equation had a coefficient of 1. And then you're going to solve for that variable. This one happened to already be solved for y. But if it's not, you're going to solve for that variable, and when you solve for one variable, it will always be in terms of the other variable, which just means that the other side of the equal sign contains the other variable. All right, step 2. You're going to substitute the expression that equals the variable solved for in step 1. So if we go back, the expression was this 3x. You're going to substitute that into the other equation, and you're going to solve for the value of the other variable, which is what we did. When you substitute that expression in, that's how you'll create that equation that only has one type of variable. That's why you're able to solve for the value. And then the last step is you're going to take that value that you just solved for in step 2, and you're going to replace it into the remaining variable into the equation from step 1. You'll write your solution always as an ordered pair, because remember, this represents where your two lines intersect. And that'll always be x comma y. Sometimes you'll have systems that don't use x and y's as the variable, and you would just write those values. You wouldn't write it as an ordered pair. All right, so let's try some examples. All right, so let's try this system. So step 1 is to solve for a single variable. We're going to look for a variable term that has a coefficient of 1 or negative 1. So if I look at my variables, the y in the first equation has a coefficient of 1, and the x in the second equation has a coefficient of 1. I could really start with either of these equations. I'm just going to start with, let's start with the second equation. So I've got x plus 4y equals 1. If you wanted to start with the other equation, you totally could. Now you're going to solve for that variable that had the coefficient of 1, which is our x. And to get that by itself, I'm going to move that 4y to the other side by subtracting it. Remember, to move a term from one side to the other, you just add or subtract it, whatever the opposite is. 4y minus 4y is 0, so now I've got x equals. On the right side, I've got two terms that are not like. So this should look a little bit like when we go from standard form to slope-intercept form. They're not like, so I can't combine them. So I'm just going to list them. It doesn't matter which one you put first. Now I have solved for x. So x equals, or is equivalent to, the expression negative 4y plus 1. So now in the second step, I'm going to write the equation that I didn't use in the first step, which is the first equation. 2x plus y equals 9. And now that I know that x is the same as negative 4y plus 1, I'm going to replace x with that expression. I need to make sure to put that expression in parentheses so that the 2 in front can be multiplied by the entire expression. And then I'll write the rest of the equation, plus y equals 9. So now I have an equation that only has one type of variable, just the y. Now we can solve for y. We're going to go ahead and start by getting rid of our parentheses by distributing that 2. 2 times negative 4y is negative 8y. 2 times 1 is 2. And then we have plus y equals 9. Let's go ahead and combine some like terms. I see the negative 8y and this 1y. Those combine to make negative 7y. I still have the plus 2, and that equals 9. Oops. Now my y's are on the left. I'm going to move my constants to the right by subtracting that 2 from both sides. So I've got negative 7y equals 9 minus 2, which is 7. And then I'll divide both sides by the coefficient of y, that negative 7. So y equals 7 divided by negative 7 is negative 1. So now I've found the y portion of my point of intersection, which is the negative 1. Okay. So now that I know that y equals negative 1, I'm going to go back and rewrite my first equation in the last box. But I want you to take a look. Here's my first equation. However, if I write this version of it, it's already solved for x. This is going to be easier to use than this one. It's going to require a little bit less work. So I'm going to go ahead and start with the bottom part, or the equation that I got at the bottom in step 1. All right, so I'm going to write x equals negative 4y plus 1. And now that y equals -1, I'm going to replace the y with -1. So the cool thing about starting with this version of the first equation is that it's already solved for x. So I don't have to move anything from one side to the other. I just have to replace and simplify. So x equals -4. Our y is now -1 plus 1. So I just need to simplify this right side. So x equals -4 times -1 is +4, and 4 plus 1 is 5. So the x value of my point of intersection is 5, and this is my solution. So remember, I could check this by graphing it in a calculator, or I could replace both the x's and y's in both equations with 5 and -1 respectively and make sure that they're both true. Let's try another one. Okay, so once again, we're going to look at our variables and see if any of them have a coefficient of 1 or -1. The b in the first equation has a coefficient of -1. So I'm going to start with that guy. 2a minus 1b equals 1. Now, a +1 would be a better coefficient, but -1 is fine. What happens if I was to solve for a variable that did not have a coefficient of 1 or -1, I would have to divide by that coefficient, which could possibly introduce fractions. And I know many of you like to avoid those, working with those, so that's why we want our coefficient to be 1 or -1. So let's go ahead and solve for that b. To get b by itself, I'm going to move the 2a term to the other side by subtracting it. Like I said, this should feel a little bit like going from standard form to slope-intercept form. I'm left with -1b equals 1 and -2a are not like terms, so I'm going to just list them. Now I've got to divide by that coefficient of b, which is -1. So I'm going to divide every single term by that -1. And I get b equals, and then on the other side I'll simplify those fractions. -2 divided by -1 is +2a, and then 1 divided by -1 is -1. So b equals the expression 2a minus 1. Now you may have noticed that this system does not contain x and y, it has a and b. So we won't write our answer as an ordered pair. If you wanted to check this by graphing, you would just replace each variable with x and y. Just remember which variable you replaced with x and which variable you replaced with y. It shouldn't make a difference though. All right. Now we're ready to write the equation we did not use in step 1, which was the second equation. 5a minus 3b equals 0. And we know that 2a minus 1 is the same as b, so we'll replace the b part of that equation with that expression. So it'll look like this. 5a minus 3 times 2a minus 1, so put the 2a minus 1 in parentheses, equals 0. And we'll solve this equation now for a, since that's its only variable. We will begin by getting rid of parentheses by distributing that -3. And I like to circle it, especially if it's a negative, so I remember to multiply by a negative. So we've got 5a. -3 times 2a is -6a. -3 times -1 is +3, and that equals 0. Let's clean up the left side by combining some like terms. 5a minus 6a is -1a, plus 3 equals 0. Let's move our constant to the other side by subtracting it from both sides. So -1a equals 0 minus 3, which is -3. And then we'll get a by itself by dividing both sides by its coefficient of -1. So a equals -3 divided by -1 is +3. So now we have the value of one of our variables, and remember we won't be able to write it as an ordered pair because it's not x and y, but we can still give the values. So now that we know that a equals 3, we will go back to our first box and we'll take the equation at the bottom because that's going to be easier than doing this. It'll avoid having to do all these steps, okay? So the equation at the bottom, we'll just rewrite it. B equals 2a minus 1. And since it's already solved for b, it will be very easy to get b's value. We will just replace the a with this 3 that we know it equals. So b equals 2 times 3 minus 1. 2 times 3 is 6, and 6 minus 1 is 5. So b has a value of 5. And then, of course, you could check your answers by plugging these in. All right. Let's try a few more. If you feel like you're starting to get the hang of this, go ahead and pause the video right now and try to solve this system by yourself. Then you can unpause and see how you did. Otherwise, just follow along with me. You don't need to pause it. So if we look at our two equations, the variable that has a coefficient of 1 is the a in the second equation. So we're going to start there and we're going to solve for that a. So a plus 3b equals negative 7. To get a by itself, I'm just going to move that 3b to the other side by subtracting it from both sides. So I've got a equals negative 7 minus 3b. Those are not like terms, so I'm just going to list them. It doesn't matter which one goes first. So now a equals the expression negative 3b minus 7. So now I'm going to write the equation that we haven't used yet, which is the first one. 2a minus 4b equals 6. And we're going to replace the a part with the negative 3b minus 7. So it'll look like this. 2 times parentheses negative 3b minus 7. And then minus the 4b equals 6. So now that we have an equation that just has one variable, just b, we're going to go ahead and solve it. We're going to begin by distributing that 2 to the negative 3b and the negative 7. 2 times negative 3b is negative 6b. 2 times negative 7 is negative 14. And then we have minus 4b equals 6. Let's combine our like terms. Negative 6b and negative 4b combine to make negative 10b. We still have the minus 14, and that equals 6. All our b's are together on the left. Let's move our constants to the right. So we'll move that minus 14 over by adding it to both sides. So negative 10b equals 6 plus 14, which is 20. And then we'll get rid of the coefficient of b by dividing both sides by the negative 10. So b equals 20 divided by negative 10 is negative 2. So that is one part of our solution. Remember, you have to find the value of both variables. So now that we know that b has a value of negative 2, we're going to take the bottom equation, the bottom version of that equation from step 1, and we're going to rewrite it. A equals negative 3b minus 7. And since we know that b is the same as negative 2, we're going to replace b with negative 2 and simplify. So a equals negative 3 times negative 2 minus 7. Negative 3 times negative 2 is positive 6. And 6 minus 7 is negative 1. So a has a value of negative 1. So there is our solution. Those are the values of our solution where the two equations intersect. All right, we've got one more to try. All right, so step 1 is to look at your variables and see if any of them have a coefficient of 1 or negative 1. Unfortunately, we don't have that in this case. So we have a choice as to which variable we're going to solve for. If I look at these, and it's totally your choice, but if I look at these, you might want to try to work smart, not harder, right? So if I look at the second equation, it's almost already solved for y. So that would be the easiest one. I would just need to divide by that negative 2, and I would be done with it in one step. So I'm going to start with the second equation because I think that'll be a little less work, and I'm always a fan of not doing more than I have to. So to get y by itself, all I have to do is divide every term by that negative 2. So y equals, and we'll simplify these fractions. 6 divided by negative 2 is negative 3x, and negative 10 divided by negative 2 is positive 5. So y is equivalent, or equals, the expression negative 3x plus 5. Now I'll write the equation that I haven't used yet, which is the 4x minus 3y. equals 24. And since y is equal to negative 3x plus 5, I will replace it with that expression. So it'll look like this. 4x minus 3 parentheses negative 3x plus 5 equals 24. So now I have an equation that just contains x, and I will solve it for x, first starting by distributing that negative 3 to the negative 3x and the 5 in my parentheses. So we'll get 4x, negative 3 times negative 3x is positive 9x, negative 3 times 5 is negative 15, and that equals 24. Should put my line. Now we're going to combine like terms. 4x plus 9x makes 13x. And we'll move our constants to the other side now. So to move that negative 15, we're going to add it to both sides. So 13x equals 24 plus 15 is 39. And then we'll divide both sides by that 13 to get rid of that 13 coefficient. And x equals 39 divided by 13 is 3. So we have just found the x value of our ordered pair where the two lines intersect as 3. So now that we know that x equals 3, we will take the bottom version of the equation from step 1, rewrite it, and replace x with 3. Y equals negative 3x plus 5. We'll replace the x with 3. So it'll look like this. Y equals negative 3 times 3 plus 5. Negative 3 times 3 is negative 9 plus 5, and negative 9 plus 5 is negative 4. So y has a value of negative 4. The point where these two lines intersect is 3, negative 4. All right. If you have any questions, write those down, and then when we come together, be sure to ask. I'll see you soon.